Good morning, all. I welcome you all for the seventh session of ATAL-sponsored online faculty development program on the topic Internet of Things, enhancing smart IoT applications using advanced processors. I would take this opportunity to introduce our resource person, Dr. Selvamani sir, who is a professor and head in the Department of Electronics and Communication Engineering at Malla Reddy College of Engineering for Women, Hyderabad. He has completed his BE, specializing in Electronics and Communication Engineering, ME in Applied Electronics, and PhD in the Faculty of Information and Communication Engineering from Anna University, Chennai. His current research interests include design and implementation of signal algorithm, biomedical application of pattern classification and machine learning algorithm, computer-aided design, signal and image processing. He has published more than 40 technical papers in various index journals and conferences. He has 12 years of teaching and research experience. He is the lifetime member of IETE, Institute of Engineers, member of IEEE and IEA-NG. He is the editor-in-chief of International Research Journal of Innovation in Engineering and Technology. He has served as lead guest editor in various leading journals, includes Elsevier, CSIR, Springer, Taylor, Francis, InterScience, Emerald, etc. He is the author of 3 books, Medical Electronics, Digital Signal Processing, and VLSI Design. Without taking much of your time, sir, I request Dr. Selvamani sir to kindly take over the session. Please, sir.
Thank you, ma'am. Thank you so much for nice introduction. Thank you. We'll start the session now.
Okay, sir. I will change you to a presenter.
Yes, ma'am. The presentation is visible to all?
Yes, sir.
Okay. So, good morning to all the participants. So today we are going to discuss about Internet of Things, trends, direction, and opportunities, and what are the challenges is there in what Internet of Things. So today's sessions, I will take what the concept in what in real time how this technology is get supported in what in the real term world, and how it can be used in what many applications. So how the this technology can be used in some other applications also. We can see all the applications one by one, and we'll see how this Internet of Things, why it is called so, and how it is working, and what the protocols it is used, how it can connect the things and do the operation in control manner with the different commands, right? Okay, we will see all the things, and one by one. So due to the bandwidth of what the internet, I'm going to stop my video. So I'm going to present my presentations alone. Okay, right, fine. So now we can see the first is what is IoT, what Internet of Things. See, you can see if you connect all the peoples together, we'll call it as Internet of People, right? In a similar way, if you connect all the devices, we can connect all the things. The things we can call as all the devices we connected, and that should be operated with some set of what the protocols and commands and rules you need to give to that device to operate in certain applications. This we call as what Internet of Things. So the IoT is connect all the things through the internet to do some operation It is called as what? IoT. We can see somewhat the applications closely. You can see all we are having got the smartphones. In smartphones, we having somewhat the different types of sensors. You can see that GPS tracking, and then mobile gyroscopes, and then adaptive brightness, and then the voice directions, which is used to recognize the user voice, and then the face detection, which is used what the many phones, many smartphones nowadays we are using what the face ID, which is used to recognize what the user. So all this what the setup, or all this what the sensor can do somewhat the different operations. So we need to have somewhat the supporting application is also required to do such kind of what the operations. See, this GPS tracking, and then the mobile gyroscopes, and then adaptive brightness, and then the voice directions, and then the face directions, all should have some different applications. How this device, or this what the application itself, we need to what do connection or communicate with each other. So if the mission to mission to what you can do some communications, that is also what possible in this what using of Internet of Things. When if we connect what the GPS tracking, when the GPS tracking is what working, automatically what the adaptive brightness will what reduce or increase. So if you are using GPS tracking, if you connect with what the mobile gyroscope, based on the direction, the adaptive brightness will be what increasing. This could be possible using of what Internet of Things. How the device are, any device should have some the capability of internet accessibility. So that should be get connected with the help of what the cloud server, and using of somewhat the protocols. So we can able to what control, we can able to monitor the device and wherever you are, right? So this is being called as the basic things of what is Internet of Things. And you can see that how this Internet of Things can be what do many things are connected. So connecting everything and embedded with electronics, and then the software, and then the sensor to the internet, enabling them to collect and exchange the data. So we need it is a platform, how it can be connect the device, and how it could be what controlled, and how the exchange of what the data can be takes place from one device to another device. We need somewhat the platform. You can see the diagram. You can see how the home, what are the home appliances we are using. You can see that smart lock will be there, smart AC control will be there, and automatic what light on and off conditions will be there. This is what the smart home appliances. A smart home, we can use what IoT technology, and that should be get connected to your cloud. And you can see the another options. You can see that the car can able to what see the fuel the level, and we can able to what monitor the speed level of the car, and all the things can be what able to control, and you can monitor the level of your fuel, and able to what monitor the speed limit, and then you can able to what control the AC the AC level also, and then automatically the light will be on and off when the person will be there in the home, and all the things will be what they're working with the help of internet. Yeah, some set of the commands is required, and that will be what the person whoever is what sitting what anywhere on the outside of the environment, they can easily what control what the device which is there in the home appliances. We can easily what control using of your smartphone itself, right? So that's the thing. It is called as the Internet of Things. Is what it just what connecting the many things. That's why I said that the device should have somewhat the capability or the internet capability, so that can able to what do some interactions with one device to another device through the internet. We can embed it with what the electronics, with the supporting of some software, and then the sensor which is used to what sense the environment, and what are the things if you want to what sense it out. We can use what the sensor, and that should be what connected to the internet, and it can start collecting the data. Suppose if you are doing some weather monitoring, it can collect the data from the weather monitoring. So in the different time interval, you can able to collect the weather monitoring reports. But that can be get collected and extend the data. The data is recorded, and what the other hand, which device is what record the data, and that should be what shared using of internet. And then see this what the Internet of Things growth, how the growth of this Internet of Things will be there in that. You can see that the year of 2003 up to what 2020, we have some database now. See that the things will be what very small. The connecting of the things be very small compared to the population. The population should be more on the earth of 2003, but the things are very small to what get connected to the internet. But in the case of, we can see 2010, the things what the population is somewhat reduced, the things connection should be what more through the internet, and exchanging of the data should be more. And 2015, you can see that more number of what the things are get connected here compared to the populations. So you can see that the growth of 2020, you can see that the things which is connected to the internet, we can able to what control wherever you are. So the 550 billions of things can be get connected, because more than that of the populations on the earth. So 50 billions of what the things 2020. See that how the devices are what get connected with the help of the cloud server. How this can be get what stores the data in the cloud and can pre-process it, and then can what communicate to the other device in control manner. See, the level of the things is also what increased more than that, of 50 billions. 50 billions, the things are what get connected using of this Internet of Things. That should be more and more than that of the population or the people on the earth. It should be what more, 50 billions. This is how the Internet of Things, the growth should be what tremendously is what takes place from 2003 to up to 2020. And see this, what the Internet of Things, this image is stating that how this about the Internet of Peoples and then the Internet of Things, how the differentiation is stating that this diagram is what stating that clearly how the populations are number of people on the earth, and then how the things are get connected to the internet. That should be more in the year of what 2020 and compared to the year of what 1990s, right? You can see that what the driver of what IoT connectivity. You can see that something like what the wireless communication protocol. We have the comparison with that. That is, we have the comparison of the access link. You can see that least or the low power consumptions, and then the greater range. We can use something like the Wi-Fi and cellular, and then the satellite and all. So this is how the connectivity will be takes place when any device should have what the accessibility of what the internet capability. So that device should be able to what control. We can able to operate the device wherever you are. This is how the driver of IoT is what gets connected with the different level. And what is the Internet of Things? You can see that you can connect the device. You can see that anytime and any place the connectivity will be there. You can see that axis level I mentioned here the figure. The dimension is what represent anything what is connection, and any place connections, and any time it is what get connected. So human to human. And then you can see that between the PCs, and then you can see that it is T to T, that is what things to things. This axis, this new dimension, it does represent the axis of X and Y, and then Z. It can able to represent this what the IoT, the concept. We can connect anything that should have somewhat the internet capabilities, and then any place you can do some connections, and anytime you can able to access that one, right? So, but we should have somewhat the standardized process is required. So when the standardized process is not there, then the system will have somewhat the failure. And see that IoT, what the perspective. This we already just now we discussed the previous slide of IoT about the perspective. You can see that the population of this 2003 are already stating that we have something like what the 500 billions, and then when you can see that how the things are connected here, the world population is, you can see that 6.3 billions. Now you can see that 2003 you may have 6.3 billions, and how many devices are what get connected, are things are get connected here. You can see that 500 million things are connected in the year of 2003. So and gradually this should be tremendously this should be increasing more. After the 2003, you can see that 2010 you may have the world population should be 6.8 billions, the device which is connected, that is what 12.5 billions. And it should be what increasing much more in the year of 2015. You can see the 7.2 billions and 25 billion devices are get connected here. You can see that the world population in the year of 2020 may have 7.6 billions, but the device which is what they connected at 50 billions of devices are get connected. See the population and see the device, how much is connected. It should be more and more and more, right? And then you see here the representation is stating that the humans and then the device. The human population is 7.6 billion, but the device are the things which is connected to the internet is what? 50 billions. This is we call as what? IoT perspective. You can see the population level and how the things are, the devices get connected. Should be more and more compared to the Earth population. And this is what the representation of what the graphical representation is stating that you may have the blue line and then the red line. It's stating that how the population, what the increases, how that what the thrice and what the more than the population, the device connection should be what get increasing here. The internet connection should be increasing what more and more. So this perspective of graphical representation, it's stating that the human being and then the internet connected devices. So the blue line is represent the human, what the beings are, the population of the human being. See the blue line here. And then this what the red line is stating that how the internet devices are connected much more it compared to the populations on the earth. It should be more and more, right? And this is what the representation is stating that the human being versus your internet connected devices. And why do we need this what IoT? What is the use of this? What is the need of this what internet of things? See, suppose you may take some example. The patient should have some what the personal assistant is required. Suppose the patient which is there in their home, the person is required somewhat the personal assistant to monitor the status of the patient. So any irregularities or any what the irregularities is present in that what blood pressures or sudden changes in your what the heartbeat level, and that data will be what present in your cloud, and cloud is what get connected to the hospital. So now the patient, any abnormality is present, even though the patient is there in the home, some personal assistant is required. So one person we cannot able to monitor the each and every time the patient status also. So for that we can connect all the data informations to the cloud, and cloud is connected to the hospital. Now the hospital can able to what access the patient status each and every minute. The patient status, a hospital can able to access to the cloud, and we need somewhat the internet connections also. So any abnormalities is present, either in what the blood pressures or heartbeat variation is present. So immediately what the hospital can dispatch what the ambulance to pick up that patient, right? So now what happened? So meanwhile, so with the hospital is came to know that the patient having somewhat a critical. So using of this what the IoT concept, that should be what know the status of the patient. Immediately the hospital can what the dispatch the ambulance to what bring back this what the patient to the hospital. So now meanwhile what happened? The hospital we should know that the prescription of the particular what the patient and what are the medicines be given to the patients, and meanwhile we can get ready for the operations theater also. So when the patient is brought back to the hospital, everything is what get ready. We can easily save the patient even it is what the critical situation. So this is how this what the IoT will be get supported to monitor even the patient should have somewhat the critical situation, or that the personal assistant is not required. The device can able to do all those things with the help of the cloud, and then the cloud we can connect it to the hospital. So all the informations can be get collected, and each and every what the variations are in that. It may be what the BP, or it may be what the heartbeat level, or any what the disturbance is what takes place in this. So we can easily access. The hospital can easily monitor the data, wherever it is the patient is there, and that should be connected, and we can easily reach the data, and immediately we can dispatch the ambulance to brought back the patient to the hospital and be ready. Meanwhile, you can be ready with the because the hospital or the doctor can easily access the patient to what the medicine will be given to the patient, and then what are the prescriptions we was assigned to the patients. We know all the database, right? So, and meanwhile, we'll get ready with the operations theater also. So when the ambulance is brought back to the patient to the hospital, so we can easily give the treatment. So don't wait. See, any patient, this technology is not get supported. So when the patient is there in the home, if anything, it will be happen immediately. What the what BP is increased, the patient is directly moved to what hospital, and then do all the checks what the check we need to do, and then after that they will use somewhat the medicines to the patient. So this you can see that the huge gap will be there. So we cannot know the patient what the level and what are the disease the patient is having. So we cannot exactly what predict of that. So when this what the technologies will be what get connected the hospital to the patient wherever the patient is there, so we can easily what access the data of the particular patient. Even some the patient is need somewhat the serious care is required, and that should be what gets supported using this technology. So this is how we can, using of this technology, we can save the what the patient lives also. So this is why the IoT is what needed nowadays. It's not only for, this is one example I'm what stating here. It's not only for the hospital. We can use what in different applications. We will see that all the applications one by one. You can see that home automation is there, and then smart cities is there, and agricultures we can use, and then what energy, and then we can use something like what the electricity side. We can use what the many applications are there. We will see one by one. This is a small example I've taken here for you. What is why do we need that IoT? And you can see the features of what IoT. The three features of IoTs are very, very important in this. One, you can say that it does connect, and then analyze, and then integrate. These three are very, very what the important features of what the Internet of Things. See, it is connect. So connect means it can connect the things to the what the IoT platform. So the connected things means that things are the device, or the electronic device, or it may be the sensor, it may be a software that should have somewhat the internet capability. So you can bring it that into what the IoT platform. So that is what the connect. We will see what is mean by the connect and what are the things are used in that one by one, and then analyze. So analyze the data collected. We cannot collect all the data and we cannot process as it is. We need to do somewhat the pre-process. So which data is required, which data is not required. So we need to do some pre-process. So that's thing that is what the second point is analyze. Analyze the data collected and use it to build the business, what the intelligence also. And then finally you can go with the integrate. So integrate the various what the models to improve the what the user experience, right? So the features of IoT should have the three things. One is connect, and next is analyze, and third is integrate. So you'll see all the things in what one by one, what is connect and what is analyze and what is integrate one by one. See that the connect. So if it is called as an IoT feature is connect, you should have the 3 point we need to what follow. One is device virtualization, and then second is what high speed messaging, and third is what endpoint management. So first you'll see that device virtualization. So the device virtualization means we should have somewhat the standard what the integration of device with IoT enterprises. So we need to what standardize the device to enterprise the platform which present on the cloud. It may be the present on the cloud, it may be the present on the server, all going to be what connected to the internet. Okay, so that we'll call as device virtualization. So the device virtualization, we need to what the standardize the integration of the device with what IoT enterprises, and we need to what how the device should be what the standard to enterprise that what the platform which should be what present on the cloud, or it may be a server, and that should be all the things should be connected to what internet. That is what we'll call as device virtualizations. And next you can see that high-speed messaging. So high-speed messaging means how the data transmissions will be takes place. You can see that can what enable what reliable, whether this should be what the secure or the bidirectional communications between the device and then the cloud. How the message or the data should be what transmitted, whether it is in a secured manner, how what the communication should be takes place. It is a bidirectional communications between the device and then the cloud. It is called as what high speed messaging. And third one, you can see that endpoint management. So the endpoint management means which device is connected to what, which device, or the data which is coming from the which device. So that is very, very important. So if you take some 40 device and 50 device, so all this 40 device and 50 device should have somewhat different IPs also. May have somewhat different IPs also. It should be programmed in different manner also. So with 40 device or 50 device will be there. The 50 device should have some different programs and different the applications will be get used, but the different IPs also will be present. So we need to identify which device is the data which is coming from the which device. We need to manage that device at what endpoint identity. So that's why it is called as endpoint management. So the endpoint management, in the sense, we need to manage the device with the help of the identity, the data which is coming from which device. We need to identify that. So that's why it is called as endpoint identity or metadata, and then the life cycle states for all the devices. So connect, it is not only we cannot stating that it can connect the IoT platforms. Inside, if you see that, you may have some design, it's the device what virtualization and high-speed messaging, and then the endpoint management. So if all the three things will be there, the device can able to comes in that what the device can able to connect with the IoT platforms, right? Next, we just see that what is that analysis? What is that analysis? So analysis, we having what the three. In this, you may have stream what processing, and next is what data enrichment, and third we will call as event store. We will call as what? The event store. So the stream processing in the sense, the data is how the data is what the come in and come out. What is very important one. The data which is coming from the which device and the how the control manner we can what send the data from what to the responding to the device, and that is very, very important. That is what the real time analysis of incoming data stream, which event what the aggregations and then the filtering, and then they can do some what the correlation. See, I will make it what give some example for this stream processing in the sense. See, this IoT, I already told you that the home appliances, suppose if you have AC, before entering to the home, if you started from the office, when I enter into the home, the AC should be what on, and this much what the point should be there in that AC. Clear or not? So automatically this process will be takes place. That's why it is called as what the real-time analysis of incoming data, streams with event of aggregations, and then the filtering, and then the correlation. The stream processing in the sense when this will not take place, when the user and then the device are the user devices, and then the device which is there in the home, that should be get connected, controlled with some commands, right? That is what the IoT, what the Internet of Things, that should be get connected. When this user is want to what before entering to the house, you can give the commands to that particular device. The AC should be turned on the point of 18 or 23 or 24. When this is what failed out, some error will happen, right? So that's why you should analyze this one. That's the thing. It is called as real-time analysis of incoming data streams with event of aggregations and filtering out the unnecessary data, and then you can do some correlation of that. Right? And second, you can see that data enrichment. So the data enrichment, you can see that enrich the raw data streams with what contextual informations and generate the composite streams. It means that so which we can the data which we can take it for the future analysis, and we can easily what understanding as well. So the data enrichment is very important in the sense. We cannot take all the data which is coming from the devices, right? We cannot take the raw data as it is. So which one is what the useful information data is there that we need to what take and do the process. So that should be, so the rest of the things can be used as the data which is not in the use. We cannot say that is not in the use of what the further process. We can use it for the future analysis, and that should be what easy to understanding also. So the data enrichment is very, very important when you are doing what analysis. And you can see that the third point is event store. So the event store, in the sense, you can see that, so this what some the amount of data which is what they integrate with your cloud service support and enable somewhat the big data analysis. The big data analysis is not a large size. In terms of GB, it should be what in terms of what the terabyte should be. So that's this called as what the big data. So the event store, in the sense, the storing of the data, how much it will be get stored in that what the cloud service, and how it will be get supported to what do the process in very effective manner. And that's what the big data analysis. The big data analysis, in the sense, here it is not somewhat the large data. It means that how the GB will be there. So the big data, you may have somewhat the terabyte of data to be there. So these are the things are very important: streaming process, data enrichment, and then what is what event stores. So next, we just go on to the next is integrate. So the integrate is very, very important. So the integrate is very, very important. You may have some enterprise, what the connectivity, and then you may have something like what the REST AP. We have some what we'll call as a REST AP, and then we will have something like what command and then the control is very, very important one. So in this integrate, you can see that the enterprise connectivity. So what is this? What enterprise connectivity in the sense? See, the integrate, you can see that what is that enterprise? What enterprise connectivity in the sense? So what the dynamically it can what the dispatch some what the critical IoT data and events to what you can use somewhat application, and you can do somewhat the process. We can see, I will give some example for this. Suppose some leakage will be there what in my pipeline or water pipeline, or some issues in the electricity. I cannot what able to contact that person to wasting my time and then tell my what are the issues I'm facing, what water leakages and then the electricity issues is. So that should be what takes place in this. So the enterprise, what the connectivity, the leakage in my pipe or the some electricity what issues. So I can contact the corresponding what the persons to what the service the service provider and sort out the issues. So this this is what we will say that the how it could be happen because of the communication of API. So this enterprise what the connectivity, and then the rest what the API. So how the request is what raised from the user, and how that request can be accepted. All these things will be what get connected: sensor, and then the gateway, and then you can go with what the cloud, right? So how the request is what given to that the cloud, how it is what take the request, and how it is do the responding to the what the client. You can see that client and then the server. The request is given, the request is accepted. You can see that the response is coming from the cloud. Now we can send the what the data frames, right? So this could be happen because of the communication of what the REST API. And how the third one, you can see that command and then the control. So the device which is what the 40 device or 50 device are get connected, or 50 things are get connected, or 100 things are get connected. How the device of what 100 number should be get controlled. So how the message should be the one message, or the device, one device and another devices get communicate with each other. How the data flow will be what takes place without clashing of one to another. So we need some set of what the command and then the control is very, very important one. That's why I said one example for you. So before and starting from when I started from my office, so I just give the command to the the AC which is there in my home. So before entering to the home, you should keep the AC point should be 23 or 24. So this is what the command and control are given to the device. So now the device is what start working now. So you can track my the point wherever I am coming, and automatically the device will be get started, and the device will be what get on. So when I'm entering into the home, I can feel that what the AC is what on. Clear or not? So this will not take place. This will not take place here. So somewhat the mistakes or some error will be present in between of this connection of the two devices. So the command and the control is very, very important one. So the REST API, you can see that. So it is what you can integrate with the cloud apps and then the AOT devices. So the REST API can able to what integrate with your cloud applications and then the IoT devices. So then only the request of the clients, the request raised by the client, that should be moved to the cloud. The cloud is give somewhat response to the cloud client. Now you can send the data frame from one to another, right? Okay, that is the use of what REST API. And then this what the command and control is very, very important one. We need to give the proper command and control to the device which is connected through the internet with the help of the cloud. We need to give what the proper command and then the control. When it is not responding, the device will not work properly. So that's why given the send message to the device from the enterprises and the mobile applications, the independent of devices are get connected. Clear or not? So the control, command and control, even if it is 100 devices or 40 devices are controlled, 40 devices are get connected. So which device is sending the data to what? Which devices? So we need to analyze that. That is what they are in the analyze. And how the control flow of the data will be takes place between what the cloud and then what the IoT devices, which is connected through the internet. Clear or not? Okay. So this we'll call as integrate. So now see, we can say is that the Internet of Things will be all the things that get connected through the internet, and with the help of following some protocols and some commands and control the devices, and what are the software and then applications that get supported, we can able to control the particular devices, and how this could be what takes place. Because of this three, what the things are very, very important. The first one is connect and analyze, and then what it is integrate. So these three things are very, very important. Not simply you can able to connect the device from one to another, IoTs and then the cloud app, we cannot connect it one to another. So we need to follow all the things of connect. If you are connecting means what are the things we need to follow. So what are the things we need to follow? We need to follow the device virtualization, and then high speed the messaging, and then the endpoint management. That is what very, very important, because which device I need to connect it to which device, and which device is going to communicate to which device, and the data floating from which device to which device. That these are the things we need to make it sure to do a connection of the device from one to another. And then the analysis, it is what very important. Analysis you can show with what the stream, what the processing. So the real-time data, how the data is the floating, that is what the data is what come in and come out. That is very, very important one. So that is why it is called as a real-time analysis of incoming data stream with the event of aggregations, and then filtering out, and then do somewhat the correlations. And data enrichment. Some enriched raw data will be there. So we cannot take all the raw data as it is for the process, and some data we cannot take in account. That you can use it for the future analysis, and we can easily understanding what the data is actually. And then the event store is also there. That is what the query. And next is what we'll see that integrate. Enterprise connectivity, REST API, and then command and control. See that this is very, very important one. IoT the protocols. So IoT protocols, we are having some very, very important one. How the flow of data will be takes place, how the devices are connected, and how this can be the data can be got flow from one device to another device to internet, and then the cloud. So all because of this the IoT protocol are very, very important. You can see that link layers are there, network layers, and then the transport layer, then application layers, right? So all the things are very important in this IoT protocol. We'll see one by one. So we can see that the link layer. So the link layer is how the data is physically sent over the network. The physical layer are in mediums, right? So the layer are the link layer. So how the data is what physically sent over the network. So the LAN, it is what the local network, it is what connected to which it is what attached. And the same, the link, the data package will be what move on through the layers and with some set of what the link layer protocols. So this link layers can able to what determine how the packets are encoded, how the packets are coded and signaled by the hardware devices over the medium to which the host of the device is what get attached. Clear or not? The link layer, in the sense, how this the layer, how the packets or the data can be what coded and then the signal by the network devices over the medium to which the host device is what attached. So this is what the very important layer is, what the link layer, which how the data is physically is what sent over the networks are in the medium. You can say something like what Wi-Fi, Ethernet, WiMAX, and then you can say something like what 2G, 3G, LTE, and cellular. So you can see something like what the low rate, what wireless personal area network, that is LRWPAN. That is what comes under what this link layer, right? All these protocols should be what very important, how the data flow will be takes place through the network, how the data flow will be takes place through the networks, and determine how the packets are coded and how the data are what the coded and signaled by the hardware devices over the medium to which the host is or the host device is what attached. So the link layer is very important one. So we are having some what the different set of what things are present in this link layer. You can see that Ethernet and then the Wi-Fi and then WiMAX and then the low rate wireless personal area network, that is LRWPA, and then the cellular. So next you can see that network layer. So the network layer, you can see this is very important one. It is what is the process of this is sending the the IP, that is internet protocols or datagrams, to send the IP datagrams from source network to destination networks. Clear or not? The internet layer, sorry, the network layer, it's setting that, or it is what the internet layer. The network layers are it may be what internet layer. It can setting the IP datagrams from the source network to the destination networks and perform the hosting address, and what it can do some what the packet routing also. So the datagrams contains, what does the datagram means? It can contains the source and destination address. So I want to transmit the data from one point to one device to another device. So what is the address of that? What is the source address and designation address? Should have that one, and that should be what present in this network layer. So the network layer, we may have what IPv4 and then IPv6 is there. The IPv4 is what the Internet Protocol version 4, which is used to what identify the device on a network using hierarchical using somewhat the addressing hierarchical addressing schemes. It may have somewhat the 32 bit of for the address size, it may be 32 bits. And similarly, you can take somewhat IPv6 Internet Protocol of the version 6. This is also what the same thing which is used to identify the device on the network. See, our network layer, it's stating that which is used to identify the device which is connected, right, with the help of the IP. So what is the source network and what is the designation networks? The device which is connected using the IP, the datagrams. What is the source network and which one is the designation networks? So we need some the protocol version is required here, and one is IPv4 and IPv6, and this two are able to can do or able to identify the device on the networks. It may be the address, it may be 32 bits, or the address it may be 128 bits for IPv6. And then you can see that one more thing is also there. It is called as we will call as over a low power wireless personal area networks, right? It is a low power wireless personal area network. That has been called as LOWPN, 6 LOPWPN. It is having the frequency range of 2.4 gigahertz. The frequency range will be there, and then the data rate will be the data transfer. It may be 250 kilobytes per again. So the network layer is very, very important, man. How we can use to what identify how the devices are connected on the network, and what is the source network, and then the destination network, how this could be connected using of IP datagram, right? IP datagrams. So that should be comes under what network layer. And this is what the very, very important one. It is transport layer. So the transport layer, we have some what we'll simply will call something like what it can able to provide what the message transfer capability is what independently takes place from end to end. No, no, no. So the end-to-end, or you can say that end-to-end message transfer, what the end-to-end message transfers will be takes place independently of what under the networks. So we can set up some what the connections and use some acknowledgement how the device or the how the device can communicate to the other devices, right? How the devices will be get connected to the other devices. How the connections are what set up between of what these two devices, and how the request can be get accepted, and how the acknowledgement is given to the what given to the particular what the device using of the cloud. Right. So this what the transport layer. It means that it provides it is what end-to-end message transfer capability independent of the what network, and set up some connections with or acknowledgements in what TCP, and without acknowledgement also, and without acknowledgement as in what UDP. So the TCP, we may have some what the data which is transferred, we'll get some one acknowledgement, and UDP, it is what the without acknowledgements we can what go with provides the end-to-end message transfer capability independently will takes place under the networks, and provide the functions such as this transport layer can provide some functions such as you can say that the error control, and then the segmentation, how the control flow of data will be takes place, and how can control the congestions is very important one. So it provides some. This is what very, very important of the transport layer of what TCP and then UDP. It is very, very important. It is transmission control protocol is TCP, and UDP is what the user datagram protocols, right? So how what are the functions can able to do this? What this can able to what find out the error control, and then segmentation, and then how the control flow of data will be takes place, how why the conversation in the data, right? So you can see something like what is this what the TCP. So transport layer, we know that end-to-end message transfer capability will be there underlying of your network, and this can able to give the acknowledgement, set up the connection to the acknowledgement without acknowledgement. TCP is acknowledgement, and UDP is what without acknowledgement. TCP is what transfer control protocol, and UDP is what user what the datagram protocols. So it is what the connection it is which we'll call as what the connectionless what the protocol also. It is useful in what the time sensitive applications. It should be used in some time sensitive applications, and very small amount of data we can able to what exchanging from one point to another point. So, and it does not provide any what the data which is guaranteed is what delivered at the what the designation sites or not. So the TCP and then what the UDP is very, very important. What the transfer protocol is a transmission control protocol. You can say some what the TCP what by the web browsers. You can see that HTTP and then HTTPS. And then you can see that something like what the emails, which is we'll call it as a connection oriented, and then the stateless we'll call it as a stateless protocols. So the IP protocols of this of what TCP, which deals about something it can send some packets. So the TCP would ensures and reliable the transmission of protocol in order, and to avoid the network congestions and then the congestions collapse. That is very, very important role of transfer control protocol. So it is used by the web server. You can use this what TCP by the web servers, like what HTTP and HTTPS, and then you can use it what email also. So this can able to how the using of this IP protocols, this one, how it can deals what the sending the what the package. Right. At the same side, this can able to ensure and to avoid the network conditions and congestions collapse also. Clear or not? This could be able to what TCP can able to what avoid the network congestions, and then what the congestions collapse also, right? Okay, so but UDP you can see that is what the connectionless protocol, and this is what the small what the amount of data we can able to what exchange from one to another, and then this will called as what the transaction oriented and stateless protocol, and does not we cannot give some guarantee the data will be delivered to that particular device as well, right? So this transport layer is very, very important one in this IoT protocol. Next, we want to what the application layer. It's very, very important one, application layer. So define it is this application what layer. It is what another what the important one. How the applications are what interface with lower layer of your protocols to send the data over the networks. How this what the application layer is interface with your lower layer of the protocols of all one to other link layers and network layers and transport layers. So how this could send the data over the network, and we can do some process of can do some what process to process, or can do some what the communications using of some ports. It can able to what enable what the process to what the process communication using of ports, This is what application layer. So under this, you can see the one by one HTTP is there, and COAP is there, WebSockets is there, MQTT is there, XMPP, and DDS, and then AMQP. We'll see one by one what is this, what this application layer, what is that HTTP. This is a we know that hypertext transfer protocol that forms the foundation of what the we know that the request response, the what it just takes from the stateless of the protocols we called as HTTP. That is World Wide Web. It is a WW will be there, and COAP. The COAP is a constrained application protocol. It's a constrained application protocols. How the mission-to-mission applications with constrained devices, constrained environment, and constrained network, the use of what the client-server architectures. All the things will be what comes under this COAP. It is what constrained application protocol. Right? How the mission-to-mission, what the connected application with the constrained device will be takes place, how the constrained environment will be there, and how the networks will be there, and uses of the client-server architectures, and everything will be takes place in this COAP. And WebSocket, we can see that this WebSocket can able to do the operation like what the full duplex communication over the single socket of communication, with the help of what the handshake signals, how the request can be accepted, how the responding is given by the what the cloud or the user. The device is connected through the internet with the cloud. The client and then server you can take. The client is what requesting something to the cloud. The cloud is what accept the response and giving the response to the client request. And now the exchanging of the data will be takes place. That's why it is called as the WebSocket. The device I want to communicate, right, simultaneously. I want to communicate simultaneously. You can go with this, what the application layer, that is what one of that is called as WebSockets. It allows to what go with full simultaneously can go with the exchanging of your data simultaneously will be takes place. We can simply say that the operation will be full duplex the communication over the single socket the connections. Clear? Next you can see that MQTT. So MQTT is what the message queue telemetry transport. The message queue telemetry transport is something like what this the lightweight of what the messaging protocol, and based on the the publish subscribe models. It's based on the publish subscribe model. The user client server architecture, and it can use the user client server architecture also. And it will be well suited for constraining your the environment, right? So this will called as what message queue telemetry transport. So how you may see something like what the publisher, and then you may have something we will call as the publisher will be there, and then the broker will be there, and then the consumer will be there. So the publisher and broker, and then the consumer. So how the message is moving on to the broker, in the queue format, and then how it can be transmitted, and finally it reaches to the consumer. That's what is called as publish subscribe model, right? And XMPP is extensible message and presence protocol for the real-time applications. We can use this. Can use this the real-time the communication and streaming XML language, right? And streaming it is extensible markup language will be there. XML data between the network entities, and support the client server, and then can support the server to server communications also, right? It can suppose the the client to server and server to server the communications. We can use XMPP, which comes under application layer protocols. And next we can see that what is that DDS. The DDS is the data distribution service. So the data distribution service is the data are centering of the middle standards, like how the device to device and then the mission to mission communications will be takes place using of the publish subscribe model. How the device to device, like we can see that XMP, how the client to server and the server to server communications will be takes place. Same thing, you can see that DDS is data distribution service. So the data distribution service is the middle standard. It means that for the device or mission to mission communications, and using this model we can use the public subscribe model. And last, you can see that AMQP. So the AMQP is advanced message queue telemetry protocol. This is the open application layer protocol for business messaging, and support for both point to point and then publish subscribe models. So the business to business it can be used in the business messaging protocols. It can be support to the point to point and then publish subscribes. And this will be called as AMQP. You can see that business intelligence, or you can see something like the Amazon and then the Flipkart, how the retails will be get connected to the user. So how we can do the payment of that, the product the user is requested, and how the payment is made, how we can give the reply to that, the user payment, how this can be get connected. You can go with this AMQP, right? So it is advanced message queuing protocols. So all these the layers are very, very important in this IoT protocols. That is link layer, network layers, transport layers, and then the application layer. I hope you understand this, these layers in clear cut format. I just move on to the next. Next, you can see that logical design of IoT. First, you can see that IoT functional blocks, IoTs, communication models of IoTs. That is the application interface. That is API, communication API. So these three are very, very important one of this Internet of Things. Logical design of IoT. First thing is IoT functional blocks IoT, communication model IoT, and then communication application programming interface. That is APIs. We will see the one by one. What is this logical design IoTs? We'll see that one by one. What is this logical design IoTs and all? So this we'll call as the logical. The design of IoTs. We may have something like application and service, communication device, communication services, cloud services is required, and application is required, management is required, and security is required. I will show you. Next slide, I will show you that each and every the blocks of this logical design of IoT, application, service, communication, device, management, security. In each and every block, what are the process will be there in that. I will show you the clear cut in the next the slide. So this is the abstract representation of the entity of all the process, but without going into the low level specification of the implementation. So what are the things is required in this? So the IoT system should the comprises of a number of functional blocks. That is application, management, services, communication, devices, and securities, right? Okay, we'll see that one by one. What is the devices will be there? An IoT devices comprises of the device that provides that if you have some device, surely you may have some sensor and then actuations, and then monitoring and controlling function should be there in the device. So the device is very important one. So that can able to provide the sensor, the sense the what the data, what applications or what process you want to do in that. The device can able to do. The device should provide something like what the sensing and then actuation in the sense it can do some, it can take the electrical or what the signals and do some what the physical actions. It is called as what actuator. So when you can take something like what the agriculture, the water irrigation is there. So how the water, when you can measure the sensor which is used to measure the level of the soil moisture. The sensor which is used to measure the level of the soil moisture. If the level of the soil moisture is not up to the level, this signal is given to the actuator. Now actuator is accept the signals and do the physical action. I just want to turn on the motor. Clear or not? How the electrical signal and doing the physical action in called as what? Actuator. So soil moisture level is identified using of sensor, using of some device. We need to measure the soil moisture, right? When the soil moisture level is not up to the level, this signal is passed on to the actuators. So the actuator is now can able to do the operation level, the physical operations it can able to do, whether it can pump on or pump off. Okay, the level of the moisture level is not up to the level. I just need to do the pump on. I just do the actuator can on the pump. Now the water flow will be takes place. Right, when that water flow will be up to the level in the soil moisture, the sensor is read out. Again, the information is given. Now the actuator is turn off the pump. So this is how the device of the logical design of IoT. That's what is called as logical design of Internet of Things. So the device that provides the sensing, actuation, monitoring, and control the functions. This is how the device can. That is what IoT system is comprises of device that should provide the sensing, actuation, monitoring, and do the control function also. So this block is very important when you are doing the logic design of Internet of Things. And next you can go with the communications. How the communications will be handle of this the IoT system. Can go with the full duplex conditions where we are requesting and then the responding and can send the data, and then it is receives the data, requesting the responding, and then you can stop that one. How the communications will be takes place in this, right? Full duplex communications will be takes place in this. That is what WebSocket conditions, full duplex conditions will be takes place. How? Or else you can go with REST, API. So two can be used as how the control flow of the data are requesting to the cloud server, and how it can be response by the device, and how it can be the device can able to send the data frames to the server or the cloud server. Just like how the client and server is working, right? So next you can say that something like the services. The services are very important. The services. The services for device monitoring, and we need to control the device control services is very important. Data publishing servicing is very important, and the service for device discovery is very important. So the services in the sense how for device monitoring, how the device is sensing, actuating, and then monitoring and control function. How the services is given to the devices. The device monitoring, the device control services is given, and then data publication servicing is given, and then the service for the device discovery. That is very, very important. That should be comes from the services, and then the management. So this can able to the management. This can provide a various function to govern this the IoT platform or IoT the IoT system. It can able to govern the IoT system in what are the procedure and process we need to use in this. So that should be present in that management. And next you can see that the security. So the security is a very important thing in this. You can see something like the secures like IoT systems, and something like the priority functions, like something like authentications and then authorization, how the data is coming. The flow of data will be takes place in proper way or not, or the device which is communicate to the other device, whether it is authenticated one or not. And then these are the context are what very important. Data security is what very important. So in this security, so the secure IoT systems and the priority functions very for the priority functions in the sense you can go with the authentication, authorization, and then you can go with the message and context integrity, and then the data securities. So these are the things will be present in the security. And next you can see that applications. The applications it can able to provide the IoT applications able to provide to interface the user or the device can be used to control and monitor the various aspects of Internet of Systems. Yeah, that is there in that applications. So the application in the sense how the interface of the device takes place, how we can control the device, how to monitor the device, the various aspects of IoT systems. That is very important in that applications. How the devices are get connected, how we can control the devices, and what are the processes which takes place in the devices, how to monitor that one. That should be present in this applications. Okay. Now I will show you that these are the things will be present in this logical design of IoT. That is device management, communication, service, security, and application. Now I will show you in each and every blocks what are the things should be present in that. If you see visually that one, it should be quite easy to understand much more what I said. You can see that this is what we have: applications, services, communication, device, security, and management. Just see that same thing here. Sorry, you can see that the devices will be there, and then the communications. What are the things will be there in the communications? You can see that the gateway, and then the routing, and then addressing, and then error detections and correction, and energy optimization, and then the QoS. All the things will be how the flow of data will be takes place in the reliability conditions. That all the things should be comes under this communications, right? And then the IoT services, you can see that IoT services. So these is being called as the IoT services here. And then you can see the management. You can see the management here, configurations, any fault, what are the performance, the member and state, all the things should be present in this. And you can come to here the security. I already told you that the security in the sense we need to the secured IoT system, and very important thing is the priority functions. The priority functions such as authentications and then authorizations, and how the message and then the context integrity will be takes place, how the secure the data flow will be present in that, how the exchange of your data will be takes place in the two devices. Authorization and key exchange and management, trust and reputation, identity management, authentications. All the secure process will be the secure IoT systems will be takes place in this security. Fine? Okay. Just to move on to the next. And this we'll call as IoT business process management. The IoT business process management, you can see something like retails and then the logistic. Suppose if you are sending some the goods are some the goods which is travel using of your vehicle, you can able to track your goods where it is coming from. You can go with that also. And then the retails, how the product will be taken by the user, how the payment will be made, and then you can take some applications like the Amazons and the Flipkart can use an IoT business process management. Next, you can see the IoT communication model. So the IoT communication models, we have the three models are there. One is request response, and second one is publish subscribe, and third one is push pull, and fourth we can see that exclusive path. You can see something like the request response. The request response communication model. See, I'm having the client and then the server. The client and server is there. The client is sending the request to the server. Because the server can able to consist of your apps and then the storage data, and then how we can pre-processing, everything will be takes place in this server. So the client can send the request to the server, So the server can accept that one and give the response to the client. So this is we called as how that the client in the sense you can take all the devices, you can take all the devices in IoT, it is act as a client. You can take something like what the computers and then the laptops and then the smartphones, how it can be what sending the request to the server and how it can get the response from the server, right? The request response is a communication model in which the client sends the request to the server and the server responds to the request. See here, when the server receives the request, it decides how to respond and fetch the data and retrieve the resources representation. We prepare the response and send them the response to the client. So this will call as what the stateless communication model. It is called as what? Stateless communication model. Hello, madam. I think someone is what speaking behind this.
Yeah, yes, sir. I just mute them, sir.
Yes, sir. Yes, ma'am. Yes, ma'am. Okay, fine. So this will call as what the request response communication model. So client, server, and then the resources we need to what access that using of server. And then publish what the subscribe communication model. Already I told you that publisher, broker, and then the consumers are there. See here you can see that how it could be what takes place in this. So three things will be there playing a vital role. One is what the publisher and brokers, and then the consumers. The publisher are source of data. Publisher are source of data, and publisher sends the data to the particular what the data which is sent to the broker. So now the publisher is not aware of the consumers, because through the brokers only we can know that the consumer subscribes to the topics which are managed by the broker. So when the broker receives the data from the topic from the publisher, it sends the data to all to the subscribed consumers. So what the process will be takes place. The consumers is not directly connected to the publisher. Through the brokers, it can be get connected to the what? Or through the broker only we can collect the data from the publishers, right? So this will called as publish subscribe communication model. So three setups will be there. One is publisher, the next is broker. At last, you may have some consumer. So we cannot directly take the topics which is coming from the publishers to the broker. The broker can collect the data which is what that are the topic are the data which is come from what the publisher, and that is what given to the consumer, and whoever it is what gets subscribed to the broker. Now the broker is give the data to the consumer. So this is will called as what publish subscribe communication model. So this is what comes under the communication model of IoTs. First one is request communication model, and second one we'll call as what publish subscribe model. First one is request response, and second one is what the publish subscribe over the communication model, and third we can see that push pull communications. The push pull communication in the sense one by one the data flow will be what takes place in the queue. So the publisher can sense the data in which the data it is what produce push the data to the queues. The data which is what sent by the publisher, it can push to the data to the queue, and the consumer can pull the data from the queues. So the data which is pushed to the queues, and then the consumer can pull the data from the queues. So see what happened in the sense here. The consumer do not aware of how the data is produced. This queue helps to decoupling the message between the producers and then the consumers. Clear or not? See here, the previous you may have the publishers and you may have the broker. We don't have the contact directly with the publishers. What the data will be transmitted to the consumer request. So that should be moved on through the broker. So the broker can collect the data or the topics or the message from the publisher, and it is given to the consumer, and the consumer whoever is subscribed to the broker. But this case you can see here the push-pull communication model in which the data producer push the data. This is what the publisher, right? It can push the data to queue, and the consumer pulls the data from the queue. So the producer and do not need to what hour of the consumers where the data is what moving on. Through the queue only can what coupling the what the consumer and then publishers. So the queue here, the queues is act as what the buffer. So which help a situation where it is what the data are the mismatch should be takes place. Are the pushing the data and then the pulling the what the data what in the consumer side and then the pushing the data from the what the publisher, right? We can what that should be the data should be what stored in this the queue buffer. So we can able to what easily what understand we can able to identify the where the data is the mismatch will be takes place in this. So this type of the communication model of IoT is called as push-pull communication model. And next you can see that exclusive pair communication model. This is just like what the client and server. The client is what requesting to the server and make what the set up the connections. And once the server is what accept the request, all the things will be what the exclusive pair communication is just like what the full duplex communication model. So how the communication what the takes place in between of the client and then the server because of the request and then the response. The client is what requesting and set up some connections with the server. The server is what accepting the request from the client and then what give the response to the client. Now the message from the client to server can be what exchanged with each other. So and at last, if it is the process will be what over the client server and then what happened the connection will be what the close request is be there and the connection close request is raised by the client that is given to the server. Now the server is what close the response. Now we cannot do the connection setup after the connection closed response is over. We cannot make the setup connections once again, right? And this exclusive pair communication model of IoT is very, very important. Just like your full duplex communication, how the communication should be takes place simultaneously. So that should be what takes place in this exclusive pair. But some sort of what the requesting and then the accepting of the requesting by the client and accepting by the server. And after that, the message from the client to the server and the server to the client could be exchanged with each other. And that's why it is called as what the full duplex communication model. And you can see that IoT, the communication, API. The IoT communication API is very, very important one. Application programming interface is very, very important one. First one, you can see that I already told you that what REST and WebSocket based communication is very, very important in what IoT. REST and then the WebSocket based communication API are very, very important one. The representational state transfer is set up what the architecture of principle, which can be able to design the web services and then the web application interface. See, right? Web services and then web application interface that focus the system resources and how the resources states are addressed and transferred. So I already told you that how the data which is coming from which device and the data which is transmitted to which devices. So this should be what takes place promptly. How the device which is connected internet with the help of the cloud support, right? With the help of the cloud support, the things are the devices are connected. The data which is coming from the which device and the data which is transmitted to the which devices, that should be in a proper manner. So we can go with this REST-based communication API. REST-based communication API. This API should follow the request response communication model. How the request response communication model, how that takes place in the sense, you can see that in requesting, the client is requesting the server is accepting the request by the client and then view the response to the client. Now the message or the data frame can be exchanged in between of the client and then the server. So that's the thing, that is what the REST API should follow the request response, the model. See, you may have the blocks here. One is HTTP client and then HTTP package and then HTTP server. And then you may have some the resources here. The HTTP command will be there. One is get, put, post, and then delete will be there. And then the REST command is also there. XML and JSON will be there on payouts. So we'll see that the important point in this client server and stateless and catchable layered system, uniform interface, and then code on demand. So what is this? What is that? The client, the server. See, you can see that the HTTP client will be there in that. And then next you can see that the package will be there. And then the server, at last we may have something like the client servers will be there. See, this REST-based communication is very, very important one, stating that how the data will be, or the packets will be what exchange between the client and then the server, the basis of what the request response communication models, right? Fine. We just move on to the next one. It is a WebSocket. It is we call as what the WebSocket based communication. So the WebSocket based communication is very, very important one. In this, you can see that the WebSocket, the client and server will be there. Just what the WebSocket is also what I already told you, that the REST and then the WebSocket based communications are two, which can able to do the process like what the full duplex manner, right? Full duplex manner. You can see that I already told you that the client server. You can see the previous one. You may have something like what the client server, and then the stateless, and then the catchable, and then layer system, and uniform interface, and code on demand. So the client server, you can see that it is what the client server concept is a separation of what the data can be what the separation of some consent. So it can allow, it can separation, it means it can allow the client and the servers to be what independently developed and updated. Clear or not? The client server, we need to what separate the allow the separation of your client and server should be what independently the client and server should be what develop and update that one, right? That's we'll call as what the client server. The main principle behind the client server constraint, the separation of the consent. That is very important one. So the client and then the server, the principle of the separation of the what the consent and results, we need to what independently we should what develop the servers and then the client, and update the same thing is what separation of the client and server is also required. And then you can see that stateless. What does that stateless means? So each request from the client to server must contain what all the informations, and that should be what understandable. What the request is raised by the client, that should be understandable, and it cannot take what the client request cannot take any much advantages to store the data on the server. Clear or not? That's why it is called as stateless. It is called as what? Stateless. It means that each request of the client, to the server, right? Each request of the client, what the request from the client to the server. So the server should what need to understand what is the request raised by the client, or what the request is coming from the client. The server is need to what understand, and it cannot take any the advantage to what stores the data, stores the data. It cannot take any advantage store the context on the server. That's why it is called as what? The stateless, right? Okay. So even the request is there to the server can able to understand what the request is raised by the client, and it cannot take what much advantages to store store the context on the server. That is very important one. So next is what? The catchable. So the catchable, in the sense, the cache constraint requires the data within the response to the request be the implicitly or explicit a label as is a catchable, or it is what? Non-catchables. It means that the client catch is given the rights to reuse the response data for later. We can, the client the request is what the rights to the server, the client which is what used to raise the request to the server, that should be what? Reusable one. So because of the cache, you can save that one, and you can reuse what the request is raised by the client. and then you can go with the layered system. So the layered system in a sense is the constraint. It is a constraint that behavior of what the component such that the each component cannot, we can see what the beyond the intermediate layers of what the link layers, and then the transport layers, and then the applications layers. So which they are what interacting with what one another. We cannot blunderly, we cannot say that applications layers and then the link layer, we cannot see all the layers in separate manner. So one layer to another layers, there may be a connection with each other. So that will be what the layered system is mainly focused on that. And then the user interface. The user interface in the sense how the communications will be uniformly takes place between the client and then the server. How the communications will be takes place uniformly. The constraint required here, the constraint is requirement is how the communications between the client and then the user must be uniformly takes place. That is what the uniform interface. And next is called as what the code on demand. The code on demand in the sense the server can provide executable codes, and then what the request is raised by the client, and to execute their what the requirement or the request raised by the client or the contest by the client, what is the requirement is there, that should be executed. The constraint is only this constraint is what is only one that is in what optional one. Yeah, the code of demand in the sense how the client request is what demanding to the demanding to the server. The server can accept and execute. That is what in the optional one. That is what the code on demand. So the REST-based communication program interface. These can use this all the 6 points are very important points. And there's a REST-based communication. How the communication is what takes place in full duplex. What is client server, what is stateless, what is catchable, what is layer system, and what is uniform interface, how uniformly the client and servers can go with what the communication with each other. What is the code of demand? What is the demand of the client is what requested, how the server, that particular demand is what executed. So these are all the very important points which just comes under what the representation state transfer. That is what REST-based communication API. Next, you can see that what is that? We can see that WebSocket-based communication. So WebSocket-based communication, you can see this is exclusively. It is what exclusively pair-based model. REST-based communication and then WebSocket-based communications. So here also what the bidirectional one, it is a full duplex communication between the client and then the server will be there. It follows that exclusive what the pair communications. That is what the WebSockets will be there. See, in that exclusive pair communications, we know that it is a bidirectional full duplex communication that uses what the connection between the client and server. Once the connection is set up, it remains open until the client sends the request to close the connections. Clear or not? So it is what stateful communications model, and the server is aware of all the open connections which just come from the client. That's what it is called as what? The WebSocket based communication, it is also called as exclusive pair communication. First, you can set up the connections and accepting the request from the client, and then give the response to the client, and then the message can be exchanged with each other. But in the case of the request base, in which the client can send the request to the server, the client which is request to the server, the client can send the request to the server, and the server is what replies to the request. It is what the stateless communication model, and each request response pair is independent of others. That is very important of request based communication model, and then WebSocket based communication model. That is request based communication model is what REST based communication is a request based the communication model. Clear or not? Request response communication model. But the case of here, the WebSocket based communication is a exclusive pair communication model. Clear or not? Okay, fine. So, but the stateless communication, the request to what the response communication model, each request response pair is independent of others. That is very, very important one. Each response, the response pair is independent of others. That is what REST-based communication model. But the case of here, you can see that it is WebSocket communication models. You can say it is what? It is a bidirectional one. It is a full duplex communication between the client and server. Once the request to set up the WebSocket communication, the responding accepting the request by the class server, initially it can do somewhat handshakes. It can use somewhat handshake, and it means that requesting the request signal is raised by the client, that is move on to the server. The server is what accepting that request or not, right? So once the server is accept the request, it can send the response to the client. Now the client, it can send the data frame. That is what the bidirectional communication. That's why I mentioned here the over persist of WebSocket connections. Now the connections will be takes place of client and server. The data frame can be move on. So the next you can see that the request is over. You can go with the connection close request. Now the server will close all the connections. What are the connections previously given to the client? All the open. Now it is be completely is about closed. This will call as closing connections, right? Okay, fine. And what are the things we discussed right now? I just put it in that the IoT, the solution architecture. You can see that the stage 1, stage 2, stage 3, and stage 4 will be there. So stage 1 and stage 2, stage 3, stage 4, you can see that the sensor, all the devices, the mobile phones, we have the many sensors will be there. So gyro sensor, and then accelerometer sensor, and then you can see something like voice recognition sensor will be there, face ID, right? And then GPS tracking, all the things will comes under the sensor, the temperature monitoring sensor, soil moisture sensor. So all the sensor can be sends the informations that should be processed to the next level. That is the next stage. It can process the data and it is more to the next level, right? And then this the second we can go with internet gateway. It is move on to the second stage is internet gateway. This internet gateway, we know that there's a physical it may generally we call as the gateway, or the IoT gateways we call as a physical device, or it may be the software program. So that serves the connections the connections between the cloud and then controllers, cloud and controller, or it can save the connections serves the connection between the sensor and then any intelligent devices. So that will called as IoT gateway. And generally the gateway means that it provides some place to do some pre-process the data locally at the edge level, before the edge level, and before sending the data to the cloud before the edge level. It can do some pre-process the data, and if the sensor which collects the data, we cannot take all the data as it is to do the process as it is. We cannot take the raw data as it is. So which data is required and which data is not required. So we can do some the pre-process. We can do some pre-process that should be takes place in the internet gateway itself before entering to the edge or before entering to the cloud. So the gateway provides a place to pre-process the data locally at the edge itself before sending it to on the cloud server. Clear or not? So this architecture is completely stating that what are the things we discussed in the previous slide, and after this you can see the slide, this architecture slide, you can see that the sensor and gateway. So the gateway can do the connections between the cloud and then the controller, or it may be a sensor and any intelligent devices. That should be physically it may be connected, the physical devices, or it may be a software programs that serves, or the physical devices are the software that serves serve the connections between the cloud and then the controllers, or the sensor and the intelligent device. It is called as IoT gateway. Right. So in this IoT gateway, we need to do all the pre-processing, everything. That is the filtering conditions, the correlations conditions, the filtering, and then the cleanups, the data. Everything will be takes place before the edge. So before the edge, we can do the pre-process everything, and before sending into the cloud, before you can do that, all the process, filtering, cleaning of the data, and then the data aggregations and conversion of A to D, and then the control manner of how the data flow will be takes place, all the things should be takes place in this internet data. That's why it is called as data acquisition system. Before the edge, that's why the center you may have the edge line is there. You can see that edge. See, before it can sending out to the cloud. So after this, what happened? We may have somewhat edge IT. It is what analytics, and then the pre-processing will be takes place in this, right? Using of somewhat the Wi-Fi here or the satellite hubs. All the things will be present in this edge IT, and finally it is move on to the data center, or it may be what the cloud server. So this can able to what manage all those things, the data which is stored and do the process. Everything will be takes place in the stage number 4. So this cloud computing, or simply will called as what the computing server services. It is a cloud computing or computing services. This cloud computing services are it delivers a different services through the internet, right? So these resources may include some tools like something like what the tools and application like something like what the data storage, and then servers, and the database, networking, and then what the software. Clear or not? Right? I hope you understand this cloud computing, and then the cloud computing, or it may be the computing services which can deliver the different services through internet. The different services it is given to the internet, through the internet, and these resources include the tools and applications like what are the resources, and then the tools and applications are what present in that, and what in that cloud. In the sense, you can see something like what the data storage we can do, and it can provide the services and databases and the networking, and then the software. Yeah, I hope you understand this. What the complete architecture of this one in clear-cut way. You can see this is what I said. It is what sensor. It can sense the informations, and it can what process to the next level. It can soil moisture sensor detect the unwanted water content in this, and then it is pass on the informations to the what actuator. This actuator is what electrical signal and do a physical actions. It can turn on the pump or turn off the pump. That the operations will be takes place what in this actuator. So this is what the device are able to what intervene the physical reality. For example, they can switch off the light and adjust the temperature in room, and can what turn off the water pump, and turn off the water pump. All the things will be takes place what actuator. The device should have some electrical signal and do some physical action in the actuator. Sensor which can sense the real what the environment, what are the data we want to sense it, and that data can be get processed to the another devices with different applications. And you can see the stage 2. That's why in architecture we have a stage 2. We'll have, see, the sensing domain is there, and networking application domain. Sensing domain, networking, application domain. And the application domain is completely moved on to the cloud server here. And then this about IoT gateway, and then the other the networking domains will be there. You can see that RFID and Wi-Fi Wi-Fi router, RFID model, and video cameras, and ZigBee. So all the things will be what get content here. After this, you can go with the cloud and interact with the other the interface devices. After the IoT gateway, what happens is you can communicate with the clouds, and then you can communicate with the other the device which is interfaced to this the gateway, right? So in the cloud, you can see that the building automation software and data storages, services, databases, and the networking and software, everything will be what get access using of this the cloud. Right. So this is how the sensor data aggregation system and analog to digital conversions will be takes place here. Sensor sends the data on how it is processed, and then how it is given to the cloud, and how cloud can do connect the different devices. So sensing domain, network domain, application domains. You can see that it is very, very important is what edge IT. So edge IT, in the sense, you can see that this can able to do some endpoint of interact with the devices one to another with the real time. The device can able to communicate and get the services, services, and finally can go with the cloud. So you can see that edge IT is where action is what includes a wide array of the sensor, actuators, and the devices. Those systems can go with our endpoint. that interact with and communicate the real-time data is very, very important one. What is this real-time data? Real-time data. If real-time data, the device is not access and process the real-time data, there may be error will be there. The device will not control by the user. Controlled by the user when the real-time data will be not present. Suppose, see, already I told you that when I started from my office, I'll give the command to the device which is there in my home, turn off the AC when I reach the home. The AC point should be what? 23 or 24. Okay, so the real-time data we need to give that. So when the real-time data is not given to the devices, the device will not operate what the command is given by the user. Right? You can go with a smart product, or it may be what the services. So the edge IT, it is mainly go with the process like what the data filtering, cleaning up, aggregations and packet contention inspections, and then thresholding, what event generations, and then combination of network and data level analytics. All the things will become under this edge IT. And after this, you may have what data center, or maybe what the cloud. So this is what how the information flow will be takes place between the edge and then the cloud. So which device is communicated, what data should have, and how the data is what collected, and which data is required and which data is not required. Go with some pre-processing one, and that exact one it is gone to the edge. Now this edge can be given to the the cloud server. Clear or not? It's good on, it will switch on to the cloud server. Or in between that, what the IoT gateways and then the on-premise of what premise service, you may have something like what the edge and then the cloud. Clear? Okay, you can see that the data center and then the cloud. So the data center means what and cloud means what. I will give something a simple example for you. So the cloud computing, we know that we can able to storing, we can able to access the data and program over the internet instead of your computer hardware drive. Right? The cloud computing means we already told you that this can able to deliver the different services through the internet. It is called as a cloud computing. And this can able to give the resources something like what the tools and applications, something like that. You can store the data, we can access the data, it can able to do services. As it can act as a server, and it can be able to give the databases, and it can connect the different devices with what the networking and with along with the softwares also. Right? It is called as cloud, or it may be what cloud server, or it is cloud computing. Right? See that the cloud and then the data center. The cloud, you can see that it is off-premise or form of computing that stores the data on the internet. But data center, you can see that on-premise hardware that stores the data within the organized local networks. This is called as a data center. And cloud is a services, it is outsourced to the third-party cloud provider. You can say that something like Amazon Web Services is there, Microsoft Azure is there. So these are the things we'll call as what the web service provider, third-party web service provider. This is what Amazon Web Services, AWS, Amazon Web Services, and then the Microsoft what Azure. So the cloud services are outsourced to the third party to provide who perform all the updates and ongoing maintenance. That should be provided by the cloud, right? Like what the cloud we are having, what the AWS, Amazon Web Service, and Microsoft Azure. I will show you what some of the what services also. And data center, you can see that the data center are typically run by an in-house IT department. In-house IT department. See the cloud is what it is different, and then you can see the data center. We can from the data center, we can take some what the requirement of what the data storage and then the application and software we can able to what take in that. Okay, fine. Okay, here itself I just want to what the wind up the session. I hope you what understand all the concept of the basic concept of what the internet things and how the blocks will be, what are the protocols, and then the architecture, and then how the communication logical design of IoTs will be there, and all the things I will discuss, and we'll wind up the session. Any what the queries, please what let me know now.
participants, if you have any queries, you can ask now.
Session level 45.
So, Dr. Selvamani, sir. Sir. Dr. Selvamani, sir. Yeah. Sir, I think we don't have any queries for the session. Sir, am I audible? Are you speaking, sir? Actually, sir, you are not audible, sir. We are not able to hear you.
Okay, okay. My voice is audible now.
Yeah, now it's clear, sir.
Okay, ma'am. Okay, ma'am. No queries means we'll wind up the session. No issues.
Yeah. Oh, sir, can you please kindly send your PPT to that mail ID?
Sure, ma'am. Definitely, I'll forward that my PPT to that mail ID.
Yeah, sure, sir. Thank you.
Okay, right.
Thank you, Dr. Selvamani Indrajith, sir, for spending a valuable time with us and sharing some information on IoT trends, challenges, and upcoming changes and demands of economy and people. Thank you, sir, once again. And once again, I thank all the participants for your patient listening. Next session will start at 11:45. You can have a break for about 15 minutes and then you can join the session. Next session will be handled by Sadil Kumar Murugesan, sir, founder of GOA of Healthcare. We just see on the session. Thank you, everyone. You can leave the session.